You know I'm back, like I never left. Another sprint, another step, another day, another breath. Been chasing dreams, but I never slept. I got a new attitude and a lease on life is a peace of mind. Seeking to find I can sleep when I die. Want a piece of the pie, got the keys to the ride and shit. I'm straight. I'm on my way. I'm on my way. Get up my way. I'm running late. What can I say? I heard you died twice. Once when they bury you in the...
Basketball shooting is a basic practice for players. The path of the ball from the players to the hoop is projectile motion. For undergraduate introductory physics course, student must be taught about projectile motion. Basketball shooting can be used as a case study for learning projectile motion from real-life situation. In this research, we discuss the relationship between optimal angle, minimum initial velocity and the height of the ball before the player shoots the ball for basketball shooting problem analytically. We found that the value of optimal angle and minimum initial velocity decreases with increasing the height of the ball before the player shoots the ball. So first of all, a basketball is a projectile when it is shot. The projectile motion causes the ball to swish through the basket even though you are shooting forward and upwards. Simply, it's because when someone throws a ball toward the hoop, the ball goes through projectile motion, because it moves along a curved path under the influence of gravity only. The closer you are to the hoop, the less horizontal distance that the ball needs to cover to make a score. Therefore, you don't need to push the ball out as much as up. Since a free throw is further from the basket, you will need to push the ball out further out than you do up. A layup, which would need more vertical force than horizontal, would be different than a free throw. The best players are best able to calculate the horizontal and vertical force needed to make the shot. The relationship between optimal angle, minimum initial velocity and the height of the ball before the player shoots the ball are shown in Figure 2. Here, we use h equals 3 meters and x equals 6.75 meters, that is the hoop distance above the floor and 3-point field goal distances respectively. We consider the optimal angle and the minimum initial velocity of 1.5 to 2.1 meters and the height of the ball before the player shoots the ball. Figure 2 shows that the value of optimal angle and the value of the minimum initial velocity decrease with increasing the height of the ball before the player shoots the ball. In other words, for basketball shooting problem, the optimal angle depends on the height of the ball before the player shoots the ball, not fixed at 45 degrees as in the case of ground-to-ground projectile motion. Do you know what is really cool? An NBA pro could take a shot from a whole bunch of different locations and make many of them. Some of these NBA players have no clue about projectile motion, although surely some do. So, how do people make these types of shots? If you say muscle memory or something like that, it's wrong. It could be muscle memory if they always shoot from the same place with the same initial velocity and angle. But these players shoot all over the place. They jump and shoot. They move the side then shoot. Amazing, right? This is a performance task in Physics 9 prepared by the second group having this wonderful roster of talented individuals. We have here Chelsea Akatan, John Bacala, Kenneth Karen, Andre Farron, Zara Karen, and Kane and Flores. We hope that you have understood the information we have gathered for you.